Yeah, good evening, everyone. If you are joining from Nigeria, and good morning, good afternoon, wherever you are joining us from, apart from this country. Uh, we are very happy to see you again today. This is another episode of the Breaking the Silos podcast, where we talk about DevOps and how to get started in DevOps. And for those of you that you have been to DevOps, how can your company or your organization leverage more on best practices and use best DevOps tools to scale up or scale down and do whatever things they want to do in their platform. So I'm very happy to be here today, and I'm very happy to have as our guest Pratamesh joining us. And yeah, let's have Pratamesh on the stage. Hello, can you hear me? Yeah, you're muted.
Yeah, I can hear you, Rashid. Good to see you.
Yeah, good evening from your side, or good evening from my side. How are you doing? Are you in the morning or in the evening over there as well?
I'm in the evening right now. So, yeah, good evening to you as well.
Yeah, yeah, we are both in the evening. So we are happy to have you on our show. This is Breaking the Silos, where we talk about DevOps, how to get started, and how to talk about topics that are interesting and how people can learn from our discussion. Yeah, people out there listening, they want to learn one or two things, and hopefully they will learn a lot from Partames this afternoon. And I'm very happy to have you joining us. Well done. To kickstart every process, I would like you to go do a bit introduction about yourself. Tell us your name, where you are currently working, and a little bit about your background, I think, so that we get to know you more before we kickstart the whole process. Thank you.
Yeah, sure. So, my name is Prathamesh. I work at Last9 as a developer evangelist. I'm part of the developer team here. And I've been part of Last9 for around 3.5 years. I started as an engineer, then managed the team for building one of our product as well. Eventually started into the developer evangelist team. And the reason for that was like I like speaking, I like talking, I like writing, and that's how I became a part of the evangelism team. But essentially, my current role means I write a lot, I speak a lot, and talk to a lot of people. That's why I'm here, I think, and would love to talk more about high cardinality and how it is affecting the DevOps ecosystem.
Oh, that's cool. Learning that from you. Like to talk about products, learning, try to get people on how to get started in a lot of things. I think the topic that we are to discuss today is an interesting topic because I've gotten a couple of questions from people that, oh, what does high cardinality means, and how does it relevant to me as a DevOps person? I think those are the questions that we'll be answering today, and I'm promising us we are going to learn a lot. And if anybody is joining us, if you have any question, don't forget to put it in the chat section. We'll pick it up from there. And if you're not joining us live, whatever time you are checking this, you can drop your comment, whether you are checking it on LinkedIn or you are checking it on YouTube. Check, drop your question, and we'll take it from there and reply whatever the question you have. So now that we know a bit about you, I think you mentioned that you are working at Cloud9, but then can you
Last
tell
night,
us a bit of what last night? Sorry,
yeah.
last night. Can you tell us about what the last night team are doing and what problem they are solving, basically?
Sure. So, Last9 is basically a company which is building tools around observability, monitoring, and reliability, specifically solving the problems of monitoring. So, we look at the observability space from the lens of a radar and a black box. Typically, you need a radar to understand the system health in real time. You need to be able to take quick decisions based on whatever threat is coming your way, right? And then be able to quickly diagnose the problem, mitigate the incident, fix it later via some debugging process. But essentially, you need real-time monitoring to make sure that you are able to be on top of all the problems that are happening, and that's why you need a very fast real-time radar view. So we build tools for solving such challenges, and yeah, we'll talk about some of that today as well, because they they are very close to the high cardinality problem. I think we'll talk about some of that. But essentially, that's what Last9 does. And we have one product which is Levitate. It's our time series data warehouse. It solves the challenges of concurrent access, high cardinality, long-term retention of data that are very prevalent in the monitoring space. So that is what we do.
Yeah, that's interesting. I think the team at last night are doing a lot of things, and one key term or one term that I've been hearing, most especially in the DevOps space, is uh, the number of nines does not matter, and does matters. I don't know. Maybe
Yeah.
you are acquainted to that kind of terms. So,
Yeah.
hearing last night for the first time, I was like, okay, these are the nine they are talking about, and there is a company that is actually taking charge of that, monitoring and providing services around those stuff. Yeah, you guys are doing a lot of things, and we would like to do a shout out to the team behind that. Well done. So, moving on to
Yeah,
the
just
first question of the
one
day. What would you?
interesting
Okay.
point, Rashid, behind the name as well, right? Like you touched upon the points of nines, right? We always chase the nines. Like you always chase the next nine when you achieve a nine, right? So the reason behind the name of the company Last9 is also that you cannot have 100% always, right? Anytime you will always be chasing the next nine, and Last9 helps you in achieving that next nine. And that is the reason why the company is named Last9 as well. So whatever products we build, they help you achieve the next nines.
Wow, wow. I think I can ask the question here that does nine matters?
Definitely, nines matter a lot, right? Because if you think about it from a perspective of customer experience is not just that, oh, my CPU went down, let me just bring more CPUs, or let me bump up the memory, or let me add more capacity, right? Even if you have a lot of servers and a lot of capacity, if your customer experience is not as expected, then your customers are not going to stick with your product. And these days, the crucial issue that happens is because we have so many choices in terms of tools, softwares, and products to use. If your product is not serving as expected, customers will choose the next product. Like it is all the game of moments, right? Like if the moment is lost, you may not get that moment with that customer again. And that's why the nines become extremely important from the context of customer experience. They are not just about availability of your product or whether it is having X number of servers or CPUs. It's all about whether you are able to solve the customer experience problem itself and mapping your availability or your observability goals, objectives to the business objectives becomes one of the crucial challenge. So yeah, definitely the nines matter a lot.
Yeah, I like the fact that relating to that to your company, it's actually make a lot of sense. Yeah, that's nice, and shout out to the team. I think we can dive into today's talk, and basically the first thing we need to get out of the topic, we've been publicizing, talking about, we want to talk about high cardinality and what could be the role of a DevOps engineer or wherever team that is managing the development and the operation part of the system. So I would like to ask you, when we say high cardinality, what do we mean? What are we passing across, or what do we want people to understand from there?
Right. That's a great start, right? So because that will also lay down some of the other things that we'll talk about in the next part of the session. But high cardinality, in a very layman's term, represents unique combinations of data, and that can be anything. Like in the context of monitoring and observability, it is of course unique combinations of the monitoring data, right? Because what happens is that when you start observing your systems, you want to observe certain attributes. Let's say I want to observe the memory of a instance or CPU of a particular container. Things are fine, right? Because the values of CPUs and pods are not fluctuating enough. And if I'm deploying only to 10 servers, I know that there will be 10 records in my database, which will have each have CPU and memory. But now suddenly I want to deploy it on Kubernetes because maybe I get more customers. Maybe I have a SRE DevOps team which is responsible to manage that Kubernetes cluster. Then maybe because my customers are increasing, I also have to do auto scaling. So my pods are never constant. Like earlier, I started with 10 servers. Now I scale out to 1000 pods, 2000 pods, depending on the traffic automatically. Suddenly, the 10 records that we were having are now getting multiplied by 2000, 10,000, 1 million, and so on, right? So you are now talking about a lot of ephemeral infrastructure. And that causes a lot of data, which is completely unique. Like every time a new pod comes up, you are basically going to create some new records that were never seen by the system before. But the observations that, or the answers that you wanted from the system, right? Let's say you wanted the answers around how many pods were up at any point of time, or what was the duration between a pod being in the ready state versus a stop state or a restarted state, right? Those answers are also going to now have to query more amount of data because you're pumping more and more data from your software systems. This was one example of infrastructure, but this can even happen in case of applications. Let's say we have a SaaS application. Now, with every customer, the data, telemetry data that we are emitting is going to multiply. Let's say earlier I had only one customer and I was emitting 1000 data points. But overall, like now, because my product was good, it was working fine. Suddenly I started getting a lot of customers. At the end of the year, I have now 1000 customers. Now, 1000 into 1000, you see the growth, right? Like it is always a
Definitely.
multiplicative growth that
Yeah,
happens
like
in the data that we emit.
an
And essentially, that
exponential
is,
growth.
yeah, that is high cardinality.
Yeah, I think looking at it from that explanation and you made, looking from that perspective, we can see that any system that is data driven, it's in one way or the other can be described or in a way come in line with high cardinality and all those buzzwords that you guys can be hearing outside there or wherever where you are hearing it. So that when according to this explanation, I think for anyone listening, you can choose from that okay, data driven system is in one way or the other related to what we are talking about in anything under high cardinality. So when we say high cardinality, we are referring to all those data and how they are being managed. You know, when your system getting logs, it's producing some set of data. When your system when you are keeping track of the number of server you are spinning up, well, you know, most especially running microservices and all of that, you need to keep track of number of pods in your Kubernetes cluster and all those stuff that is happening there. So I think it actually makes sense for us to talk about everything that we need to get our system, most especially when we say data driven. So with that, I would like to ask the next question. That okay, as I'm a listener, and I think some of our listeners too, what they will be thinking is what I wanted to ask at the moment. That okay, we know that high cardinality and data driven system are going in line with each other, and you've talked a bit of how that is very important to us. The question I would like to ask is, so is there any approach being taken from the past, and what are the new approaches that currently exist in managing the high cardinality of a system, and most especially when we talk of data driven system, and what are
Right.
the new ones? I think we can start with the old approaches, the past approaches, then we can move on to the new approaches and the impact they are making.
Yeah, that's a good question. So, if you think about how the software world has changed, right? We are talking about self-driving cars these days, and you cannot observe the surroundings when you are inside a self-driving car, or a self-driving car cannot itself observe the surrounding if it is working on a 140 megapixel camera. It needs a very high resolution camera where signals are coming from different directions, and then it is able to take the decisions in real time, whether to cross the signal, whether to stop, whether to take a turn, because ultimately, like, somebody's life is at stake, right? Who is inside the car. So essentially you need a very low fidelity high resolution data to make like to take quick decisions about what is happening. And that is very true with our data driven software systems as well. For example, if you're running a web API, right? you need to be able to understand how it is performing, what are the latencies, what are the thresholds. Now, if you have a SaaS application, you may need it per tenant. If you have infrastructure, you may need it per container, per pod, per instance, and so on. So effectively, the data increases a lot. And if you think about the past approaches of like solving this, or even the current approaches in a lot of ways to address these issues, right? That depends on at what stage of your monitoring process you are trying to solve it. So I like to look at the monitoring from five different stages. You have the instrumentation on one side, which is all about emitting the telemetry data, either from your applications or from your infrastructure components or from product metrics, business metrics. Then you have ingestion process, which is not just like it is before the storage, like whatever happens at the boundary of the software system where you want to push your telemetry. Then there is storage, then there is query, and then there is query is part of alerting as well. So I'll club visualization and alerting as part of the query. So you have instrumentation, ingestion, storage, and query. Now, typically, current way to solve or address high cardinality is solve it either at the instrumentation layer or at the query layer. But there are troubles doing that. And the problem there is if you solve it at the instrumentation layer, what that means is that you either drop those labels or data, or you combine them into some aggregated fashion. You combine like two high cardinality metrics into a single one by adding some naming conventions, or you remove that data altogether. You ask your developers basically that no, our system cannot support it, because if we try to ingest it, maybe we will be able to ingest it, but query will become problem, because at the time of querying you have to search over a large search space, get everything into your search result, and then that causes problems to people. So typically to answer your question about the past approaches, the high cardinality challenge is solved at the instrumentation layer or at the query layer. But those are very they have their own problems if you solve it there, because you are basically saying that I don't need the answers anymore. Instead, if you solve it at the ingestion layer, then you may be able to retain the data in some form and at least be able to get answers out of that data. But yeah, essentially the way to solve it right now or in the past is all by either stopping the instrumentation, not doing the instrumentation at all, or moving that data to some other system. That is also one way that a lot of people address it. And that also creates silos of data. Like a part of your data is in one system, a part of your data is in another system. Like a lot of people I have spoken to, they use two Prometheuses. One Prometheus for storing some metrics, and then some critical metrics they store at a completely different Prometheus, because they don't want to worry that, oh, if my the one Prometheus, if it goes down, maybe my important metrics will also get affected. So let me just store them at a separate location altogether. A lot of people use Postgres or databases for these critical metrics as well. But essentially, you are trying to circumvent the problem either by moving data to different places or by not instrumenting it at all.
Yeah, I think it makes sense a lot. Like, okay, looking from the old way of thinking and the way we are thinking currently, yeah, it actually makes sense. When you are with a team and you guys and you in the team, you need to make decision. There will be a lot of suggestion around how let's keep to one server, most especially when it comes to saving logs and taking metrics. When you want to talk about Prometheus, for instance, now there will be suggestion around let's stick with one server, Prometheus server, or there will be another suggestion, let's stick with two, so that we have issue with one, another one picking us. We still have our metric and logs and every other thing in another one. So I think it's this comes down to any approach the organization is using, and I think every team has a back or any explanation for whatever things they are doing. Yeah, it actually makes sense. And thank you so much for giving us an insight around that. I think we are DevOps. Let's just assume that, or we are DevOps enthusiasts for those that are watching and people that will be watching later. Yeah, I think at this point we have been talking about all those DevOps tools, some of those DevOps tools that were normally used, like Prometheus for keeping track of metrics and logs and all of that. So I would like to ask a direct question. Probably somebody from somewhere watching is trying to ask that same question as well. That okay, can you can you describe any a real life scenario where managing high cardinality data driven system pose a very high challenge, most especially when we are talking about DevOps to the DevOps teams, and probably you have a suggestion around that. You know, you've been working with a lot of people, you've worked with a lot of teams, and I'm very sure you have experience around. Okay, so probably managing high cardinality system will be, these are the general problem we normally face, and these are how we normally resolve it. If you have anything to say around that, I would like to. Yeah.
Definitely. So these problems generally arise. Let's say I'll give you an example of one of our customer. So they have a way to send push notifications to their company, their customers. It's a SaaS product, and they send out push notifications to a lot of their customers for their customers, which eventually go to their customers. Like basically, it's like a hub and spoke model where they will push out notifications on different channels like email, WhatsApp, or any other social networks, and so on. Eventually, what happens is that when your accounts or your customers increase, the only way to sort of manage and measure the performance in real time becomes critical for them. And the use case there is because they have to offer the SLAs to their customers. And to measure that SLAs using logs is error prone. You have to solve it using metrics because it has to be done in real time. It has to be done in an aggregated way. You cannot do it on logs because that becomes a post factor activity. Some logs are sampled, some logs are not sampled. So there is no accuracy of data. So it has to be solved using metrics. But then you run into the challenge of high cardinality, or they ran into challenge of high cardinality because as the campaigns were increasing, as the accounts were increasing, your data exponentially grows. And the understanding or key learning there is that dimensions only will keep growing. Like as a business, we will always want more and more dimensions, attributes to be added that we need under observation from an understanding perspective about how our product is being perceived, how it is being used. So dimensions always increase. And the problem with handling such systems is you need to have a like a engineering bandwidth to manage that system. Like you need to have a probably a dedicated team to make sure that you have everything set up, and you need to work with your developers team to maybe change the instrumentation, drop certain metrics that are not required, and so on. So effectively, there is a lot of wastage of data in that case, right? Like 80% of the metrics are mostly unused because you're storing them, but you cannot query them because when you go to query them, your dashboards don't load. If you have a high cardinality situation. And even if you Google about Grafana dashboards being slow, right? Like a lot of people, how they respond to it is check first if you have a high cardinality situation. Maybe that is the reason why your dashboards have become slow or latent, right? So that is when then the DevOps and SRE teams have to come together, understand, oh, this service started having this new metric from the last deployment. Then they have to ask that developer team what changed. Are you okay with us dropping that metric on the our side, or do you want to drop it on your side? Let's do some negotiations and then come up with a plan to address that situation. But during that time, your monitoring is affected. So ultimately, the task that you needed to do as a SRE or as a DevOps person, which was about monitoring of your system, that you cannot do. You have to go behind other parts of the system and try to fix that itself. Like you're basically blind, right? During that period. And different things have different needs, right? Like certain metrics are about performance. You need to have them if you're doing SLA reporting to your customers. Certain metrics are all about, like, let's say scaling strategies, scale out, scale down, and depending on that, your metrics will either increase or decrease. So constantly worrying about that and worrying about how your system is working, monitoring system is working, is where you get distracted, is where you have to spend a lot of time. Instead, you can spend that on your product. Like a lot of times we have seen, and this was a very interesting example that I heard from one of our customers is, uh, like in the past when they were not using our product Levitate, there was a situation, a weird kind of a situation where their engineering manager basically called everyone in the team and told them to not run Grafana dashboards for that particular incident that they were debugging, but instead asked them to join a video call on Zoom where he opened the Grafana dashboard and then they debugged it together. But the reason behind doing that was because the monitoring system had become so slow that even 2 3 people loading the Grafana dashboards was causing massive delays. And he didn't want to get completely blind to the system. Like, he didn't want it to crash. So he just called everyone on phone, asked them, no, shut off your laptop. Like, don't load the Grafana dashboards. Just come and join a call and we'll debug it there. But these are some of the real challenges that people run into, especially when you have systems which have different strategies in terms of scale, as well as requirements in terms of real-time monitoring. Let's say your business depends on situations where customers' traffic is very seasonal. Like, let's say you have an application which is all about share markets. People sign up during specific periods of the day. Then there are spikes during the day, during the business hours, and then you know that, oh, I may have to scale out because my traffic is going to be variable during this period. A lot of times, because of such unreliability of monitoring infrastructure, you also cannot store data for long term. Because let's say you want to do a trend analysis that last year during Black Friday, this was the infrastructure capacity that I had. Maybe I can use that information to take better decisions this year, but I don't have access to the data at the same granular level. I may have downsample data over 3 months, or I may not have that data at all. And these are some of the real-time situations that you will run into. The only way to sort of look at them or solve them today is either use multiple tools or compromise somewhere so that you can get around with the problem.
Yeah, I think that actually makes sense. And what Keating they will tell us in computer science classes, everything in computing is trade-offs. You have to make trade-offs. You have to choose the whatever one works for you, and the one that works for you is what you will go for. I think it actually makes sense, most especially if you are working in a cross-platform team or team that cut across a lot of people. Most especially when you have experienced people around, you'll be like, I had this experience working with this team over there and we've faced this same challenge. I would suggest let's go for this, let's go for that. And that will push us to our next question, which will be around, is there any standard that we need to follow or any kind of frameworks? As a person from last night, and I know in one way or the other, all these challenges that I've mentioned, you even mentioned it as well that, oh, when you are trying to do this, this happened and all of that. With that, is there any crafted standard or frameworks that we can follow as a DevOps person to be able to focus or combat these challenges we just mentioned now?
That's a very interesting question, because if you think about the way currently people solve it is around the instrumentation and the query phase, and I think that's where the standards do exist right now, where there are a lot of documentations around how you can drop levels, how you can remove or combine different metrics into one metric, and so on. So that is what exists today. But essentially, what we need in terms of solving or addressing this issue is, it may not be solved 100%, right? Because as you said, it will be a trade-off. All you need is a control lever mechanism to manage it so that you can not run into a situation where you don't have access to that data. What you need is some way or some flexibility so that you can still have access to the data, and then you can query that data, you can use that data for whatever the reason that you started it emitting with. So that is, I think, where we need some guidelines, and one of the way that we look at it is basically look at it from a decision tree perspective. Like, when you run into this situation of high cardinality, probably observe, orient, decide, and act, right? Like, first observe where is the problem, then focus on the particular metrics or system which is causing this high cardinality. Then decide, okay, out of these 2 3 options, should I just drop the labels, or should I create an aggregation, or should I do something else which can help me in solving the problem? and then act on it. Don't go by just the default mechanisms that are out there without understanding why the cardinality has grown up. Because sometimes it can be accidental that somebody mistakenly started emitting a high cardinality label like a user ID or a campaign ID, like a UV ID, right? It will always create new entries all the time because every time that is generated, it is unique. So such situations can be avoided by relabeling. But sometimes you want to do a aggregation on account ID because you need tenant level observability. Now, dropping a tenant is basically saying that, oh, I mean, you are not even then able to do tenant level observability from your across your infra app product and business metrics. But in that case, you can perhaps create an aggregation which can create a subset of the data specifically for that use case, which can help you in having access to the data in a way that can load things faster, or it can help you in alerting as well. So what you need is like a framework or a decision tree framework with control levers, because as SREs and as DevOps engineers, right, like we already know reasons why we are emitting the data. Very rarely we will be in a situation where we don't know why something has been instrumented. It typically starts with a reason, but then we run into a situation where we are not able to use that data effectively. So ideally, you need like uh, proactive answers to these questions. And while I don't think there are guidelines as such that exist, the way we look at it and we talk about it is around the OODA framework. Like you need tools which can tell you that this is what is happening across my system, across all my metrics. This is what you can focus on right now because this is where the fire is coming from. Maybe a cardinality, suspicious cardinality alert that can tell you that, oh, these are the couple of metrics that have started misbehaving from last 10 hours, and if you don't focus on that, maybe they will crash your system in next 3 hours, right? Like a suspicious cardinality, a threat alert. You need mechanisms then to decide what to do. That's where you need a framework and tools like ability to create aggregations, ability to decide to drop data, but not just have one single solution, right? Like options based on your use cases that you want. And then ability to act, which is all about taking decisions not via instrumentation or query, because if you do at that stage, you're already saying that I don't want that data anymore. Like you're okay with not having access to that data, but instead doing it at the ingestion layer or at before the storage layer will help you in a way that the data that will be stored will be managed, because you can create these aggregations in real time, which will reduce the amount of data, and it will also help you in terms of making sure that you are not getting penalized for getting it queried.
Yeah, cool. Yeah, I think that makes sense. And checking up our time, I can see that we've been talking around the point of view for developers and DevOps engineer. I think it will be cool for us. We can talk a bit from business side of things. Okay, probably we have a business person watching us, and we want them to benefit from our show. It's part of what we do actually, and we want to help both developers and organization and business person. So that will lead me to my next question. We've been talking about high cardinality and the responsibility of DevOps, both DevOps process and DevOps team, since we started. I would like to ask, do you have any scenario or any example of how managing this high cardinality in a data-driven system has improved the system in a way, or yeah, let me just put it that way, improve the system or give a very good result at the end of the day when it was well managed. And yeah, I think I don't know, maybe the question is straightforward, but then if not, I can retake it.
Yeah, perhaps if you can retake it, that will be awesome.
Yeah.
I lost you in the middle.
Okay. So now we've been talking around the how high cardinality, the DevOps responsibility when we talk of a data-driven system. But then our discussion has been more focused on around the developers and DevOps engineer. So I want us to shift a bit to the business side of the story.
Right.
look from business side. Okay, from that, I want to ask: is there any kind of example of effective where um this high cardinality are being managed efficiently,
Yep.
and at that point, have you gotten a result where this management that is very significant and efficient enhance the performance or probably the decision making capability of the DevOps team or the stakeholders or the developer or any other team within the development and every the whole process of system? Yeah. Does that do you take that now? Or do you get it?
Yeah, yeah, makes sense. I'll give you an example of a scenario where a company was migrating their managed like product into a multi-tenant architecture. And typically in that case, what happens is that you have SLAs promised to your customers. But when you are migrating from a managed platform to a multi-tenant platform, you have shared infrastructure, right? And what that means is that there can be a situation where you run into a noisy neighbor problem, like one customer basically hogging all the resources and that impacting performance of other customers. So you need to have ability to monitor things at a tenant level or at a customer level, right? That's where you run into the high cardinality challenge, because as you introduce the tenant ID label, all your bottom level labels for infra product application, they get the same multiplicative effect that we discussed earlier. Like all of them get multiplied by the account ID or the tenant ID that you want to monitor for. But having access to this data is extremely important while you are migrating your customers, because you want to tell them that, oh, while I'm migrating, I'm able to maintain your SLAs, and also the costs are also under check. Like as a company, also you're not paying more, and also not getting affected by this migration while you are doing some performance optimizations or changes, right? So that's where having access to this high cardinality data, including these tenant IDs and other things, makes very important difference for the business. Because otherwise, the only way to get access to this data is like getting information from engineers or having dependency on engineers and people in your team, technical people in your team in some ways, right? Because there is no automatic way of seeing dashboards or setting like ability to set alerts on top of that. It's always about, oh, we don't have it at the monitoring level, so we'll have to make some compromises to get that data. But I think that is one example that is related to a case where business needs high cardinality data, and you need to have ability to sort of store that data and utilize it for specific scenarios.
Yeah, I think it makes sense. Makes sense for any business person watching. I think you've not missed anything. You've talked about the developer sides, the developer engineer parts, and currently we talk about how it could be helpful for the business person. I think we've done a lot of job, and because our time is fast running, the one category of people that I think we've not talked to directly, although what we have been discussing is for everybody since morning, and the one particular set of people that I would like us to talk more about is people that are interested in getting started. My last show, I have friends or people that join. Making comment that, oh, you guys were mentioning some buzzword that I don't understand. I was just trying to follow along. So I don't want that to happen in this show. So I want us to talk a bit about the enthusiasts, people that are trying to get started. So what are those skills that you think is necessary for anybody that is interested in getting started in high cardinality or talking about data driven system, or even you can talk about generally DevOps. What are those
Yeah.
skills? Yeah, it's left to you. Yeah.
Yeah, so you can like basically read about it. There is a lot of material available that you can read about. I'll also paste a link here about some of the blogs that we have on our last time blog around high cardinality. So this is also something that you can check. And the best way to do it is, I mean, the only way to understand the pain is being able to be in that situation. Like the best way is probably if you're doing any sort of monitoring as of now, try to see and analyze how your metrics are behaving. Try to see if you are running into a situation where you are not able to query the data, and then decide, oh, why it is happening. Is it because of the cardinality issue, or is there something else that is happening? If it is cardinality issue, then understanding which metrics are causing problems, and then realizing, oh, why they are causing problems, and then think about a solution, right? Because instead of jumping to a solution, I think the best way would be to experience that problem first, before trying to solve it. You can even set up a local Prometheus, local Kubernetes cluster to simulate the situation as well. But if you have a production setup or a staging setup, that will be the best place to try this out, and then then move to the next step of actually trying to fix it.
Yeah, cool. Nice. Thank you for your time. I think at this point we can show a bit of demo and how this thing that we have been talking about consolidates, and so that people that are watching live can see how it works, and people that will be watching it can see as well. And if we are ready for that, I think we can spin up a screen sharing, and
Yeah, just a
we can get
second.
to show. Yeah, okay, we can get to show something for. So while we are doing that, I want to appreciate everybody that have been staying. This is We've been here for over 40 minutes and you are still here. Thank you so much for joining us. And we'll still be having some of those stuff. Yeah, we'll be having some of those stuff. Another session very soon. We'll be talking. We are having a plan for our open source discussion, which is Open Source Wednesday. We'll have a time to talk around what open source is all about. We just finished Oktoberfest, and what next after Oktoberfest? I think some of those you watch me showing you how to make your PR back then during the month of October. For those of you that missed that, you can check it in the somewhere on my YouTube channel, so you'll be able to see it and start your journey as a open source contributor. You can contribute to anything, be it in DevOps, in and any other places that you wish you want to get started with. So that's just a bit of announcement. And I think one last announcement before we move on to the demo. GitHub Universe, they did something amazing. They had GitHub Universe last week and they were selling tickets for GitHub Universe 2024. So if you are interested in joining them in San Francisco next year, I think they are doing 160% discount for you. Check out, just put it on Google, GitHub Universe. You'll be able to find our event website and you can go there and purchase the tickets. So with that being said, we can move on to the demo and so that we'll have to leave here as soon as possible.
Perfect. You can see
So
my screen, right?
exactly. So
Awesome. So we talked about streaming aggregation, right? And being able to define these aggregations in real time at the ingestion layer itself, so that before the data gets stored, I'm able to create almost like these materialized views out of my time series data. So the case in point here is that if you store the raw metric, your cardinality will explode. You will run into query challenges. You'll run into challenges of slow alerting and so on. But instead, if you can create an aggregation which will aggregate the data in flight before the data is getting stored, then it can help you in managing the cardinality, because effectively you are reducing the cardinality. I'll also show a demo of that, but first I wanted to show you how you can basically define that streaming aggregation using Levitate. So you just define it using a PromQL itself. PromQL is the query language of Prometheus. But essentially what you say is that, okay, this is the aggregation. This is the name that I want to give to that metric, and that's all that is needed. What Levitate will do in this case is, as the data is coming, at the ingestion layer itself, it will basically create this my app service throughput metric and my app tenants throughput metric from these PromQLs, so that you can, in your alerting and in your Grafana dashboards, you can just query these metrics instead of querying the original metric. And now I'll also show you the performance difference between both of them, right? Because that becomes very critical. Like what I'm getting by doing all of this, what I'm getting by defining these streaming aggregations. So for that, I will show you a quick demo that we had collected for one of our like a production scenario. So on the left hand side, you have around 1000K samples, and this is the cardinality of the original metric. You can see that there is some histogram query. which is running on the original metric. And this query basically is very slow because it runs on the original high cardinality metric, takes around 21-22 seconds. On the right hand side, I have the derived metric cardinality, which is the cardinality of the metric which is created by defining this streaming aggregation. That query works on a aggregated metric like we saw in the example in our editor, but essentially that query is defined by using this prompt shell and with this name. Now this query runs very fast because it only has 27 samples, right? Like from 1000k we reduced to 27. So that is a massive decrease in cardinality, and because of that this query loads extremely fast in around 200-300 milliseconds, and this query still keeps loading. So that is kind of the massive performance boost that you get via the streaming aggregation pipeline of Levitate. And most importantly, this is all real time and accurate data, right? Like, because if you see the chart on the left and right side, they are essentially the same. So while you are getting benefit of faster queries, you are not losing out on the accuracy and the accuracy of the data. Like whatever you will get from the raw metric, you will get the exact same data from the aggregated metric as well. So that is one of the benefit. But I think this will give you a glimpse of what is possible using these streaming aggregations, like what kind of performance boost that you get, and also how easy it is to just define on the platform, within Levitate itself. Additionally, we also offer like creating it via GitOps pipeline. So a lot of people have already set up their CI/CD pipelines via GitHub. We just provision a repo for them where they can commit these YAML configurations that we saw in the editor. They can commit it in GitHub. From there, it will put it in Levitate via an API call. So we support that workflow as well. But I mean, that is I think a short demo that I had to explain what impact you can get in terms of like managing or reducing the cardinality using streaming aggregations of Levitate.
Yeah, I think that's a lot of. I think for people that are having confusion to understand what we've been talking about with that data you show us, I think that actually summarize it all, showing you we're talking about data, how data have been streamed, and how they have been managed. If you want to query it and all of that, those are the buzzwords that we have been using since morning. And I think seeing
Yeah.
it from the screen, from the demo, I think you'll be able to get one or two things from there. So thanks so much for joining us this evening. But before we leave, there's one question that we do ask ourselves on this podcast or on this show, whatever things you want to call it, is that okay? You've talked to us about everything. What is your final thoughts for us? Okay, you've talked about a lot of things, technical, non-technical, and all. So, what is your final thought for us?
I think one of the key aspect of being a good DevOps and SRE engineer is being able to not take decisions on the whim or without understanding what is happening. I think it's very crucial to spend time in terms of understanding what is happening in our system in terms of, and I'm talking about monitoring and observability perspective, of course, but being able to understand what is happening in the system and then take decisions instead of like trusting our instinct, because while our instinct can be correct 80-90% of the times, it can also be incorrect a lot of times, because we can think something that why it is working this way based on our past experience, but the situation might be completely different. So as an engineer, I think we should always trust systems to answer the questions that we are asking it. But that also means that systems have to be reliable to be able to answer those questions, and we need to monitor the data, instrument the data, so that we can get those answers from the system. But essentially, I think that is what I would love to end this on. That as an engineer or as a DevOps engineer, we need to understand why things are working the way they are working. We need to spend some time on it to really understand the nitty-gritties before coming to a conclusion.
Yeah, I think that's very important. Know what is going on before you take your decision. Not just, oh, that's how we do it. Let's just do it that way without knowing what is going on behind the scene. That's very important takeaway there. So with that, I would like to appreciate you for joining us today. We've learned a lot from your discussion, from this particular discussion, and you've shared a lot of things with us. Thank you so much for joining us, and to the participants or attendees, people watching us live, we really appreciate you for joining us. And very soon, I'll be making announcements on what we'll be discussing next on this show. Breaking the silos. We still have one more show before the end of this year, where we'll talk about what's our plan for next year. We want to make it more interactive than this, and every other plans that we have for you, we'll announce it on our next show, and we'll advise everybody to join us live the way you've been doing. So thank you so much, everybody, for joining. Thank you, Prathamet, for joining us this evening. Thank you, and everyone. Bye for now. Bye bye.
Thank you.